Hello, Math Study students. Welcome to another online lesson. Today's lesson is going to reinforce what we went through last class regarding correlation coefficient and the line of regression. We'll refresh how to do that on a calculator, as well as going into a little bit more information on those topics. So our learning intentions: we're going to use the calculator to find the equation of the line of regression, which is a best fit line, as well as finding the correlation coefficient, or Pearson's product moment correlation coefficient. And then we're also going to talk about the reasonableness of predictions or estimates made with a regression line. So if we use that line or equation of that line to make predictions, how good or how reasonable are they? And we will know we are successful when we can use the equation of the line of regression to make predictions about the data and interpret the reasonableness of those predictions. So I'm going to start off with a little table here. This table we can use as a way to sort of gauge how good our correlation is based on our Pearson's product moment correlation coefficient. So remember, R is our correlation coefficient, and R can be a value between 0 and 1 or between 0 and -1. The closer we are to 1, the better our correlation is. The stronger it is. The closer it is to 0, the weaker it is. And if it's positive correlation, and if it's a negative number, it's negative correlation. So you'll notice here on this table that I have these absolute values around my R's, meaning that I'm not worried about positive or negative. So each of these numbers could be positive or they could be negative. If they're positive, obviously it's positive correlation. If your R value is negative, it's negative correlation. But we're talking about the descriptor part, the adjective part. If your R equals 0, or the absolute value of R, which again is 0, there's no correlation, absolutely none. If you have a value of R that's between 0 and 0.5, we have weak correlation. And we're not concerned about any values between 0 and 0.5. If you're below 0.5, it is weak correlation. And that would be totally appropriate for a test as well. If it says describe the product moment correlation coefficient and it's less than 0.5, you just say weak. Low would be fine as well. Then when we get to the 0.5 to 0.75, we say moderate. That's sort of in between. It's not great, but it's not terrible. Moderate. I very, very rarely see an IB question come up that isn't extreme one way or the other. So the moderate doesn't happen very often, but again, 0.5 to 0.75, it's moderate. And then all these other ones, we're basically saying it's strong or high correlation. It's good. 0.9 above, we can say very strong, but honestly, I don't care about that. As long as you know that 0.75, and again, we can say it's some sort of strong correlation. Anything between 0.5 and 0.75 is moderate, and anything less than 0.5 is weak. Obviously, 0, no correlation, and then the 1, it's perfect correlation, meaning that every point on our scatter plot would be on the best fit line. The question is, do I want you to necessarily remember those? And yes, I want you to know that 0.5 and below is weak. I want you to know that 0.75 and above is strong, and everything else is moderate. When using a regression line, estimates, predictions are said to be unreliable if we have two things happen. Number one, if we're making a prediction using a best fit line, and our best fit line has a weak correlation, meaning our R value, or the absolute value of the R value, is less than 0.5, so example like 0.4 or negative 0.3 or something like that, then the line's not very good. It doesn't represent the data very well, and it's not a good use, or it's not a useful tool for making predictions off of. So number one, if you have a low R value, any predictions made with that regression line or line of best fit are not going to be very good. Secondly, if the data that you're asked to predict about is outside of the range of data, and we'll look at that in a moment coming up here, but think about running a race. I can train to run, like, say, a 4-mile race and work up to it, and run 1 mile and then run 2 miles and 3 miles and eventually 4 miles. Run that race. And then let's say I'm averaging an 8-minute mile. Can I then use that to predict how fast I would run in a marathon? Marathon's about 26 miles. Well, no, it's very unlikely that I'd be able to run an 8-minute mile during a marathon because it's just so much longer. It's so far outside of the range of data that we have measured for myself. I would keel over and pass out probably halfway through that because, again, I didn't train for it. So we only want to make predictions within our range of data. So if you were asked how fast do you think I could run a 2.5 mile race, that I could do because it's within the range of measured data that I have if I've trained for a 4-mile race. So that's the idea there. So here we have a set of data. The following table shows the costs in Australian dollars of 7 paperback books chosen at random with the page numbers, the number of pages of each book. So the idea is the number of pages going to have some sort of correlation with the cost of the book? Bigger book, more pages, should it cost more? And I'm going to pull out my calculator to start with because it asks me to find the linear correlation coefficient, R. Well, that's just our correlation coefficient, so I need to put this data into the calculator. So I've got 2 lists, and I will go to Stat, Edit, and I can clear out the data I already have in here. And you can put this in your calculator as well. So 50, the lists are going horizontally here on the video, but we're putting them in vertically. 330, 400, 450, and then one more, number 630. Okay, so that's my first set of data, my X, my page numbers, and we want to know if the page numbers affect the cost here. So we have 6, or they have a correlation anyway, 6.5. Oops, I don't know why I wrote 6.5. It's 5.4. 0.4 and 7.2, 4.6, 7.6, 5.8, and 5.2. Make sure that when you're done, your lists have the same amount of data, meaning that they end at the same spot, and I can see that mine do. To get the correlation coefficient, again, make sure that your diagnostics are on. We get to that by going to second catalog. So second 0, and then making sure diagnostics are on by pressing enter twice. But once you've done that, you never have to do it again. So those of us in class last time, we did that in class, so you don't have to do it. Again, you go second, catalog, scroll down so you get to diagnostics on, hit enter twice, and you're good to go. But for the rest of us, we are now going to go to stat, calculate, and we're going to calculate our line of regression, which is option 4. I probably should have put L1 comma L2, but it defaults to that if you don't change anything. And so it says write down our correlation coefficient. Well, our correlation coefficient is the R value, and I see that right here. So my R is negative 0.1414. And, sorry, pausing for one moment. Okay, sorry about that. So our correlation coefficient, I'm sorry, was this value right here, which is negative 0.141. Negative 0.141. That's our correlation coefficient, or R. So what does that tell us about our correlation? It means that obviously we're negative because there's a negative sign. So we have negative correlation, and it's low. It's way less than 0.5, or negative 0.5 in this case, or the absolute value of that. So this is weak, very weak negative correlation. And usually after it asks you to write down the correlation coefficient, it'll then say, describe the relationship. And that's where we would put these words down, or describe the correlation, or what's the relationship. It's a weak negative correlation. Again, because our absolute value of R is way less than 0.5, and it's definitely negative. All right, so write down the equation of the line of regression. So this is just going to be in the form of y equals ax plus b, which is like mx plus b. A is our slope, b is our y-intercept, and those values were given to us right here. I'm going to round those each to 3 significant figures. So I've got y equals negative 7.54, which we see right here, x plus 6.21. And that is our line of best fit or line of regression, which we got straight off the calculator there. Oops, and Mr. Peacock made another error here because I'm now noticing that we say e to the negative 4, which means that we need to move this decimal place over 4 spots. 1, 2, 3, 4. So let me rewrite that. Y equals, and then negative 0.00. Again, if I move this 4 spots, 1, and then 1, 2, 3 zeros, so 0, 0, 0, 7, 5, 4. X plus 6.21. And I'm glad we're doing the hard one together. All right, part C. Stephen wishes to buy a paperback book that has 350 pages in it. He plans to draw a line of best fit to determine the price. State whether or not this is an appropriate method in this case and justify your answer. Well, remember, X represents our number of pages. And so if he's going to buy a book that has 350 pages in it, there's nothing to stop us from taking this X right here, plugging in 350. And then we can just reach for our calculator and plug in these values. Negative 0.000754 times 350 plus 6.21. And we would have an answer, and that would estimate our y value, which is our cost. So that's how we would use this equation to make a prediction. Well, they're not actually asking us to make the prediction. They're just saying, is this going to be a good fit or not? Is this going to be a good prediction? And there's definitely one big reason why this is going to be a terrible prediction. Now, there's two things that we need to check. The first of which is our data that they're asking us about within our range of data? And our range of data goes from 50 all the way up to, I think it was about 520 was our last value, or certainly over 450, which is the last one I see that's not being covered by my calculator. And 350 is well within that range. Well within that range. Sorry for these background announcements here. And so 350 pages within our data, so that's not a problem. But the problem is this R value is terrible. It's a very, very weak correlation. So we can't make a reasonable or an appropriate method of estimation using this equation line because our correlation value is very, very weak. So state whether or not this is an appropriate method. No, it's not appropriate because the correlation coefficient is weak. Or you could say something like our correlation coefficient is below 0.5. So I've got no additional book work for you, and we're going to be continuing on the worksheet that we got last class, and I'll give you another worksheet this class. I just want to make sure that you can, again, do these things that we have on our learning intention. We want to make sure that we can use that calculator to find the correlation coefficient and the line of regression, and then we want to be able to comment on the reasonableness of predictions made using that. All right, we'll see you next class, working more on correlation coefficient and line of regression.